All right, section 9-7, similarity transformations. All right, so rigid motions and dilations both preserve angle measure. Fill in the blanks with one of the following. All right, so rigid motions preserve distance, while dilations do not preserve distance. So similar polygons are polygons that have corresponding angles congruent and corresponding sides proportional. All right, so we say two figures are similar if and only if there is a similarity transformation that maps one figure onto the other. So an example, when a figure is transformed by a similarity transformation, a similar figure is formed. So if the image length of a dilation is 5 centimeters and the corresponding pre-image length is 2 centimeters, circle the scale factor of the dilation. Well, that would be 5 to 2. If the scale factor of a dilation is 2 to 3 and the image length is 4 feet, circle the corresponding length. Well, that would be 6. All right, so let's try to draw a transformation here. So triangle LMN has vertices of L at -4, 2, -3, 3, and -1, 1. Suppose the triangle is translated 4 units right and 2 units up and then dilated by a scale factor of 0.5 with the center of dilation at the origin. Sketch the resulting image of the composition of transformations. So step 1, what I like to do first is find the translation here. So we first find the new points by adding 4 to each x and subtracting 2 from each y. So L prime is going to become 0, 4. M prime becomes 1, -1, and N prime becomes 3, 3. Then I multiply each one by a half. So this becomes 0, 2, this becomes 0.5, -0.5, and this becomes 1.5, 1.5. Now I just graph these last points. So we have 0, 2, and that's going to be L double prime. 1/2, 1/2, it's going to be right here, and that's going to be M double prime. And we have 1.5, 1.5, and that's going to be N double prime. So here is the triangle. All right, so what is a composition of rigid motions and a dilation that maps a trapezoid to this trapezoid? Okay, so what I like to do is write down all the coordinates. So for the pre-image, we know A is -6, 2, B is -2, 2, C is -1, -2, and D is -8, -2. For my image, we had the coordinates 3, 1, we had the coordinates 1, 1, we had the coordinates 0.5, -1, and we had 4, -1. All right, so I need to determine what happened. Okay, and I'm going to choose 2 points and follow their movement from pre-image to image. All right, so point A corresponds with point M. Point D corresponds with point P. Segment AD is located to the left of that figure, and segment MP is located to the right of this figure. So a transformation I could use so that AD is parallel to MP and the corresponding points located quadrant would be a reflection. The trapezoid is larger, okay, so I need to reduce this by performing a dilation. Scale factor should be about 1/2. So what I'm going to do is reflect x across x equals 0. Then I'm going to perform a dilation using a scale factor of 0.5. So compositions of rigid motions and dilations form a special class of transformations. These transformations that map pre-images and similar images are called similarity transformations. Two figures are similar if and only if there is a similarity transformation that maps one figure onto the other. So is there a similarity transformation that would map triangle JKL to triangle RST? If so, we need to identify the similarity transformation and write a similarity statement, and if not, explain. So first thing is, let's identify the lengths. So we know JK is 10, we know KL is 12, we know LJ is 16, RS is 12, ST is 16, and TR is 20. Corresponding sides of similar figures need to be proportional. To determine if the corresponding sides are proportional, I set up a proportion. So the following proportion I'm going to set up is this thing. So plugging in the numbers is 10 over 12 equal to 12 over 16. Simplify it. 5 over 6 is what to 3/4? It does not equal. So corresponding sides are not proportional. So triangle JKL and RST are not similar. There is not a similarity transformation that will map these two triangles onto one another. All right, so for triangle TUV shown at the right, give the vertices of a similar triangle after similarity transformation that uses at least one rigid motion. So step one, let's go ahead and write the vertices for T. So -5, 4, U is -3, -1, and V is -1, 3. All right, so when a triangle is reflected across the line, what happens to the corresponding angle measures and the length of corresponding sides? So the angle measures and the lengths of sides of the corresponding parts, sides, do not change. All right, so recall what we do with the following. So this would give us the following. So T prime would give us 5, 4, U prime would give us 3, -1, and V prime would give us 1, 3. All right, so when a triangle is dilated by a scale factor, what happens to corresponding angle measures and like the corresponding sides? So the angle measures of the corresponding sides are equal. The lengths of the corresponding sides are proportional. So if I did a 1/2 of all of these x's, I would get 2.5, and I would get 2, and I would get 1.5, and I would get -0.5, and I would get 0.5, and I would get 1.5. So let's graph those final dots on my pre-image up here. So 2.52, 2.52 would be right here, and that would be T prime, double prime. 1.5, -0.5 would be right here, and that would be U double prime. And 0.5 and 1.5 would be right here, and that would be V double prime. And there is my new figure. And that's the end of the section.